Get this, your next boss might not even be human. Seriously, they could be an algorithm. And as AI starts moving from the server room straight into the boardroom, that brings up a huge question. How in the world do we write the rules for our new AI managers? Let's dive in and look at the blueprint.
Okay, first things first, this is not science fiction. This is happening right now. AI isn't just some fancy assistant anymore. In some companies, it's already making the big executive decisions. We're way past AI being just a tool. We are now in the era of AI as the decision maker.
And I'm not just talking theory here. Look at this list. These are actual AIs that have held or still hold top-level corporate jobs. You've got Mika, a humanoid robot CEO over in Poland. Alicia T, a top manager in Sweden. In Hong Kong, an AI called Vital actually votes on investment decisions. And in Abu Dhabi, Aiden Insight literally sits on a corporate board. These aren't concepts for the future. They are active members of management today. The shift has already begun.
So, if AIs are already calling the shots, what's the big problem? Well, it all comes down to this really fundamental translation gap, a gap between how we, as people, understand rules and how a machine actually follows them.
Here's the core of it. Human decisions are what you'd call social constructions. Our rules are squishy, they're filled with nuance, context, and the shared cultural understanding. We get it through language. But AI decisions? Those are technical constructions. They need crystal clear, unambiguous instructions that, at the end of the day, just become ones and zeros. There's zero room for interpretation. And this is the crucial point, right? Our entire legal system, all of our corporate rules, they're built for people, for social systems. But now we're trying to jam those rules into technical systems, and that creates this massive, dangerous gap where the whole spirit of a law can get completely lost when you try to translate it into code.
Believe it or not, this idea of turning law into a perfect, computable system, it's not some new Silicon Valley thing. It's actually a really old dream that thinkers have been kicking around for centuries, long before the first computer was ever a spark in someone's mind.
Yeah, way back in the 17th century, the philosopher Gottfried Leibniz had this wild idea. He imagined a world where any disagreement, even a moral one, could be solved with a pure certainty of math. Instead of having these long, messy debates, you could just sit down and say, all right, let's calculate.
And then about a century later, a guy named Pierre Laplace took it even further. He saw probability theory as just common sense reduced to calculation. He actually predicted that one day, math like this would be better than human reasoning. Without even knowing it, they were laying the philosophical groundwork for the AI managers we're dealing with today.
So, how do we possibly bridge this giant gap between our human rules and the machine's code? Well, one idea that's been proposed is a blueprint, a structured model for actually creating policies that an AI can understand and follow. Now, this model here kind of shows you the core of the solution. You see that book icon right in the center? The one labeled Algorithmic Dictionary? That is the engine that makes this whole thing work. It's the central hub for translating our world into the AIs.
You should think of this algorithmic dictionary as a kind of Rosetta Stone. It takes a big, abstract human idea like fairness or due diligence, and it defines it with a precise mathematical formula that a machine can execute without getting confused. It's the absolute essential translation layer.
Now, before you can even start writing this dictionary, everybody involved has to agree on two basic ground rules. First, the law of large numbers. Just think of it like polling. The more people you ask, the more accurate your result is going to be. For an AI, it just means more data equals more reliable answers. Second is the central limit theorem, which, in simple terms, just says we can make pretty good guesses about a whole population by just looking at a small sample. Agreeing on these is like agreeing on the laws of physics before you try to build a house.
But here's the catch. These principles are all based on probability, not certainty. And what that means is an AI doesn't just give you one perfect answer, it gives you a range of likely answers. This ambiguity is a massive headache for corporate governance, which, loves certainty. The whole Enron scandal is a perfect, real-world example of this problem.
So researchers got their hands on that massive dataset of emails from the Enron collapse. They told a machine learning classifier to go find any suspicious messages. But here's the key. They didn't just run the program once. They ran the exact same program on the exact same data 200 times. And the results were, well, they were staggering. The number of suspicious emails it flagged swung from a low of about 8,600 to a high of over 15,000.
Let that sink in. The same program on the same data never gave the same answer twice. This is the reality of working with probabilistic AI. And the takeaway here is absolutely critical. We have to build a new social contract that accepts this ambiguity and learns to manage risk, instead of pretending our AI bosses can spit out a single perfect truth.
Okay, so this brings us to what is probably the hardest piece of this entire puzzle. How do you take a concept that is so human, so subjective, and so important, like fairness, and turn it into something a machine can calculate?
Seriously, when a company policy says you have to be fair, what instruction is that actually giving the AI? It's a command that is totally impossible to execute unless you give it a much more specific mathematical definition.
And if you don't give it that definition, you know what happens? The AI just reflects the biases it found in all its training data. In one experiment, a large language model was asked to just generate some names for a CEO. The result? 85% of the names it came up with were male. It wasn't programmed to be biased, it was just spitting back the statistical patterns it learned from the real world.
Here's the really mind-bending part. There's not just one way to calculate fairness. Researchers have found at least 20 different mathematical definitions for it. For instance, you could use statistical parity, which makes sure the outcome is the same for all groups. Or you could use equal opportunity, which makes sure the rate of mistakes is the same for all groups. They sound similar, but they can lead to wildly different results. Choosing which definition to use isn't a technical choice, it's a fundamental policy choice, and it has massive real-world consequences.
And this is where it gets dangerous. Right now, because we don't have a formal algorithmic dictionary, these incredibly important ethical and legal decisions are just being made by default. They're being made by engineers, inside a black box, often without any explicit guidance or debate or oversight from anyone else in the company.
So, the ultimate takeaway here is this. Whether we like it or not, we are writing the foundational laws for our new AI partners in management. This is not some technical challenge for programmers to figure out in a back room. It is a fundamental question of governance, of power, and of ethics for all of us. The only real question left is, who should be the one holding the pen?